Hello everyone, welcome to Gradeup. I'm Vikas Sir. Very good evening to all of you. Sorry the session got delayed for some time. And so today we are going to discuss some important formulas for IC engine and REC. As you know that in this week we have conducted few lectures on IC engine, that is air standard cycle, and refrigeration air conditioning on vapor absorption refrigeration system and vapor compression refrigeration system. And today I am going to tell you some important formulas for these topics. Okay? So let's begin. Instead of wasting much time, let's begin the session. Okay, if we talk about the IC engine, for IC engine we have discussed, there was a lecture on air standard cycle. Okay? In air standard cycle, I have discussed about basically Otto cycle, diesel cycle, dual cycle. In the Otto cycle, what happens? Otto cycle is a constant volume cycle. It is also called constant volume cycle. This cycle is basically used for petrol engine. Okay, which is used for petrol engine. The working fuel is petrol here in the cycle. Okay, and what is the formula for efficiency? For an Otto cycle, if you represent the Otto cycle on a PV diagram, that is pressure and volume diagram, it consists of two isentropic process. From 1 to 2, it is isentropic compression, then it is constant volume heat addition, then again expansion, isentropic expansion, followed by constant volume heat rejection. Since in this process of, in the Otto cycle, two processes are constant volume process, that is heat addition and heat rejection take place at constant volume, that's why it is also called constant volume cycle. And the efficiency of this Otto cycle is 1 minus 1 by R over gamma minus 1. Okay, this gamma is called as adiabatic index. It is equal to adiabatic index. Okay, and R is called compression ratio. R is compression ratio. Now this compression ratio is equal to volume before compression divided by volume after compression. Okay. So if this is volume before compression, which is V1, and this is volume after compression, which is V2, so ratio of V1 over V2 is equal to compression ratio. Okay. And also this total volume is equal to sum of swept volume plus clearance volume, and this V2 is the volume, that this volume is called as clearance volume. So we can divide this by Vc. So compression ratio is equal to 1 plus Vs over Vc. Okay, where Vs is the swept volume. This swept volume is equal to pi by 4 d square into L. D is the bore of the cylinder and L is the stroke. L is the stroke length. So these are some important formula from Otto cycle. Okay. Now if you move on next to the diesel cycle, for diesel cycle is the common cycle which is used for diesel engine. Okay, where diesel is used as a working fuel in the diesel cycle. It is used for diesel engine. Okay, so all the cars and all the vehicles which work on diesel fuel, they are working cycle is diesel cycle. In the diesel cycle, basically it consists of two isentropic process. Okay, then heat addition in the diesel cycle is at constant pressure. Heat addition in the diesel cycle take place at constant pressure. Then expansion is again isentropic and heat rejection is again at constant volume. So heat rejection is at constant volume and heat addition is at constant pressure. This is the diesel cycle. So this is the difference between Otto and diesel cycle. That diesel cycle is a constant pressure cycle because heat addition is at constant pressure. Okay. Now how to find the efficiency of diesel cycle? Efficiency of the diesel cycle is equal to 1 minus 1 over R power gamma minus 1. Okay. Divided by rho power gamma minus 1 divide over rho gamma times of rho minus 1. This is the formula for finding efficiency of the diesel cycle, where R is the compression ratio. R is the compression ratio, and this rho this rho is called as cutoff ratio. It is called cutoff ratio. Now this cutoff ratio rho is equal to V3 over V2. It is equal to V3 over V2. If this is 1, 2, this is 3, this is 4. Okay. So the ratio of V3 volume after this constant process, constant pressure process divided by volume before the constant pressure process, it is equal to cutoff ratio. So you have to just put all the values here in this equation and you will get the answer, okay, of efficiency of the diesel cycle. Next cycle is dual cycle that we have studied in this lecture, and in the dual cycle is also called as semi-diesel cycle. Semi-diesel cycle. I'm not going to tell you the formula for this, but yes, in the semi-diesel cycle, what happens? Firstly, heat addition is take place at constant volume, and then at constant pressure, and finally expansion will take place at constant isentropic expansion, and then heat rejection at constant volume. So in the case of dual cycle, it is also called as semi-diesel cycle because heat addition take place partly at constant volume and partly at constant pressure. Okay, so it is also called semi-diesel cycle because working fuel in the dual cycle is diesel fuel. Okay, so diesel is used as a working fuel, that's why it is also called semi-diesel cycle. Okay, so this is semi-diesel cycle, and the formula for efficiency is not that much important because, well, if you see the application of diesel cycle efficiency of the diesel cycle lies between Otto and dual cycle lies between Otto and diesel cycle. Okay, so this dual cycle is used in most of the application. Okay, most of the vehicle we use semi-diesel cycle where the compression ratio is optimum. Okay, for optimum compression ratio we normally use this dual cycle. Okay, so this is the advantage of dual cycle, and it is also called semi-diesel cycle. Okay, now this is all in the formula of the air standard cycle. Apart from these three cycles, we have studied about some other standard cycle, which are, first cycle that we have studied is Atkinson cycle. What is Atkinson cycle? Anybody? I hope you remember this Atkinson cycle. In the Atkinson cycle, this first process is constant isentropic compression followed by constant volume heat addition, and then finally the expansion take place up to this lowest temperature. Up to this lowest temperature, the expansion take place in the Atkinson cycle. Okay, and then finally heat rejection take place at constant pressure. Okay, so this is Atkinson cycle. So you have to remember, well, if you want to know the standard thermal efficiency value of the Otto and diesel cycle, it is around 30 to 40%. It is between 30 to 40%. Okay, that is the value of efficiency of the Otto cycle and diesel cycle. Okay, well, thermal efficiency of Otto cycle is more as compared to diesel cycle. Well, and compression ratio of diesel cycle is more as compared to Otto cycle. Okay, so this is the Atkinson cycle consisting of, this is isentropic compression, this is isentropic compression, and this is expansion, isentropic expansion. Then this is constant volume heat addition, and expansion take place up to the lowest possible pressure. This is the lowest pressure up to which the expansion will take place. This is the Atkinson cycle. Next cycle, that is Stirling cycle. What is a Stirling cycle? In the Stirling cycle consists of two isothermal process and two constant volume process. Okay, it consists of two isothermal and two constant volume process. Okay, so they are two constant volume process. This is isothermal, not isentropic. This is isothermal expansion. Okay, so the heat addition and heat rejection take place at constant volume like Otto cycle, but here the expansion and compression will be at isothermal expansion and compression in the Stirling cycle. Okay. And next cycle is Ericsson cycle. Ericsson cycle is almost It is almost similar to the Brayton cycle, which is gas turbine cycle, which consists of 2 isothermal process and 2 constant pressure process. Okay. So there are 2 isentropic process and 2 isothermal process. So this is isothermal. This is constant pressure heat addition, constant pressure heat rejection. This is again isothermal. Okay. So this is Ericsson cycle. Okay. 2 isothermal process and 2 constant pressure process. This is Ericsson cycle, and finally the other air standard cycle is linear cycle. In the linear cycle, basically it consists of 1 constant volume heat addition process. Heat addition take place at constant volume. Then after that, expansion take place at isentropic expansion. Isentropic expansion will take place. And then heat rejection will take place at constant pressure. Okay. So this is linear cycle. This is used in modern pulse jet engine. In modern pulse jet engine, we use linear cycle. Okay. Is that clear to you? So linear cycle is used in the modern pulse jet engine. Okay. So these are some air standard cycle that you should remember. Okay. So these are some important formulas of air standard cycle. Now the next thing that we have discussed is, in this week we have covered refrigeration and air conditioning, and in that we have covered 2 important topics: vapor compression refrigeration system and vapor absorption refrigeration system. So if we talk about vapor compression refrigeration system, which is also called VCRS, yeah, Sonu Kumar, this is important, that's why we are discussing here in this lecture. If it not have been important, then definitely I have not included this in this live session. Okay. So VCRS is the vapor compression refrigeration system that we have discussed. Before we start with VCRS, let us understand this VCRS is also called vapor compression refrigeration system. Vapor compression refrigeration system. Okay. In the vapor compression refrigeration system, the refrigeration effect is produced by compression of the dry saturated vapor inside a compressor. Okay. And basically in VCRS, before starting knowing to understand what is VCRS cycle, I have told you about 2 important applications of refrigeration. One is heat pump, another is refrigerator. Heat pump and refrigerator are 2 important applications of refrigeration. This heat pump, COP of the heat pump is equal to higher temperature over higher minus lower temperature, and COP of refrigerator is equal to lower temperature over higher minus lower temperature. This you have also studied in second law of thermodynamics, because these 2 devices are based on Clausius statement of second law of thermodynamics. They are based on Clausius statement of second law of thermodynamics. Okay, and the working cycle of heat pump and refrigerator, working cycle is reverse Carnot cycle. Reverse Carnot cycle is the working cycle of heat pump and refrigerator. Okay, so what is reverse Carnot cycle? If you operate the Carnot cycle in the opposite direction, that is, this is 1, 2, 3 and 4, it will become reverse Carnot cycle. If the reverse Carnot cycle is working in the anti-clockwise direction, then it will become reverse Carnot cycle. Okay. So the working cycle of heat pump and refrigerator is reverse Carnot cycle, but we have to discuss VCRS. Now in the VCRS, I have also discussed about what is refrigeration effect. Okay, refrigeration effect is the unit of refrigeration, okay, and which is equal to 1 ton of refrigeration. It is equal to 1 ton of refrigeration. This 1 ton of refrigeration is equal to 3.5 kilowatt, which is also equal to 210 kilojoule per minute, which is also equal to 50 kilocalorie per minute. Okay, so this is the unit of refrigeration, which is called 1 ton of refrigeration. So in the exam also they can ask you that 1 ton of refrigeration is equal to, all these values are correct, but the difference is only in the units. You have to take care of the units. Okay. Now in the VCRS cycle I have told you that basically it consists of 4 important components. One is compressor. Okay. So the dry refrigerant vapor will go into the compressor. From the compressor, after getting compressed, they will go into the condenser. After heat rejection in the condenser, the working fluid, which is a refrigerant, will go into a throttling device, and from the throttling device the heat will be absorbed in the case of in an evaporator. Okay, so these are the 4 components of a VCRS cycle. Okay, and how to draw this cycle on a TS diagram, on a temperature and entropy diagram? This cycle can be drawn like this. Sorry, this is somewhat wrong. It can be drawn like this. The process, the throttling process, shown by a dotted line. So this is 1, 2, 3 and 4. Okay, so this is the vapor compression refrigeration cycle on a TS diagram. Okay, on a pH diagram, this can be represented like this. This is on the pH, which is pressure and enthalpy diagram. Okay, so one question can be asked in the exam, that why we prefer dry compression over wet compression. Dry compression, which is compression in the saturated. If we compress saturated vapor in the compressor, it will have more advantage as compared to wet compression. If the compression is taking place from this region, from this point, then refrigeration effect will reduce and work of compression will decrease, but refrigeration effect will also decrease. Okay, so wet compression is not basically used. That's why we use a flash chamber. Okay, a flash chamber is used in vapor compression refrigeration system to separate the liquid and vapor refrigerant. Okay. Now, what is the COP of a vapor compression refrigeration system? It is equal to refrigeration effect over work input. So this refrigeration effect will be equal to H1 minus H4 over H2 minus H1. Okay, because if you see here, this is H2 minus H1, this is the work input, and H1 minus H4 is the refrigeration effect here. So this is the work input, and the ratio of this refrigeration effect over work input is called COP of a vapor compression refrigeration system. Okay, now one important thing that I have to tell you is that there are some factors which affect the coefficient of performance of a vapor compression refrigeration system. So first effect is reduction of evaporator pressure. Okay, if you reduce the evaporator pressure, then what will happen? Refrigeration effect will reduce, work input will increase, COP will decrease, as volumetric efficiency will also decrease. Okay, so these are the effect of reduction of the evaporator pressure on the different components like refrigeration effect, work input, COP and volumetric efficiency. Okay, second effect is increase of condenser pressure. Increase of condenser pressure. If you increase condenser pressure, then what will happen on the COP? If you will increase the condenser pressure, then refrigeration effect will reduce, work input will increase, COP will reduce, and volumetric efficiency will also reduce. If volumetric efficiency is reduced, more mass of refrigerant has to be supplied into the evaporator. Okay, so volumetric efficiency should not decrease. Okay, third effect is effect of superheating. What is the effect of superheating? If you increase the superheating, in the case of superheating, refrigeration effect also increases and work input also increases. Both the things increases. So if refrigeration effect and work input both increases in superheating within the evaporator, superheating within evaporator, in that case both refrigeration effect and work input will increase. In that case COP can increase also and COP can decrease also. So COP will increase for R12 as the refrigerant. If R12 is used as the refrigerant, then COP will increase, and if ammonia is used as a refrigerant, that case COP will reduce. Okay, and the last effect is effect of subcooling. Effect of subcooling. See, subcooling always increases the COP. You have to remember, COP always increases. COP always increases on subcooling because refrigeration effect will increase and work input will remain same. Okay, work input will remain same and COP will increase. Refrigeration effect will increase, so that's why COP will always increase with subcooling. Okay, so these are important points that I need to tell you. And the last thing that is important is cascade refrigerator. Cascade refrigeration is done in the vapor compression refrigeration system, which is also called multi-stage. It is based on multi-stage compression of refrigerant vapor. In the cascade refrigeration system, it consists of two cycles, lower cycle, vapor cycle, and condenser of upper cycle, condenser of lower cycle becomes evaporator of upper cycle. Evaporator of upper cycle. You have to remember this thing in the case of cascade refrigerator. Okay, and what is the advantage of cascade refrigerator? To achieve very low temperature in the lower cycle. To achieve very low temperature, we use cascade refrigeration. Suppose that COP of upper cycle is COP1 and lower cycle is COP2. So COP of cascade refrigeration will be equal to COP of cycle upper cycle into COP of the lower cycle divided by 1 plus COP of the lower cycle plus COP of the upper cycle. Okay, so this is a formula for COP of the cascade refrigerator. Okay, so these are some important points. And the last thing is that flash chamber is a device. Flash chamber is a device which is used to separate. Flash chamber separates liquid and vapor refrigerant. Liquid and vapor refrigerant. Okay, what is the advantage of flash chamber? Flash chamber separates the liquid and vapor refrigerant, and it reduces size of evaporator. Okay, installing a flash chamber will reduce the size of evaporator and no effect on COP. It will have no effect on the COP. This is very, very important. COP will have no effect by using the flash chamber. Okay, so flash chamber is basically installed before the evaporator to separate the liquid and the vapor refrigerant, so that only vapor refrigerant goes into the evaporator. Okay, so that's why we use flash chamber. Okay, now the last thing is vapor absorption refrigeration system. Vapor absorption refrigeration system is also called as waste heat refrigeration system. Waste heat refrigeration system, because this refrigeration system does not uses a compressor as a work input. Okay, in the vapor absorption refrigeration system, we don't employ a compressor. Instead of compressor, compressor is replaced with absorber, pump and generator. Okay, so in the vapor absorption refrigeration system, the compressor is replaced with absorber, pump and generator. Okay, absorber has the same function as evaporator. It will absorb the heat. Generator will supply the heat. Okay, it will absorb the heat or it will reject the heat and it will supply the heat. Generator will supply the heat like evaporator and absorber will reject the heat like the condenser. Okay. So the working fluid used in working fluid is a combination of either ammonia and water, or it is a combination of lithium bromide and water as the refrigerant. Okay. In this ammonia and water working fluid, ammonia acts as a refrigerant in the vapor absorption system and water acts as an absorbent. Okay. In the case of lithium bromide and water, water will act as a refrigerant and lithium bromide will act as an absorbent. It will absorb the refrigerant vapor. Okay, so these are the two working fluids which are used. Well, analyzer and rectifier are also a part of vapor absorption system. Analyzer will analyze whether no liquid refrigerant should go into the evaporator. It should go into the condenser. So it actually analyzes that thing, and rectifier actually corrects that if somehow some liquid refrigerant actually passes from the analyzer, it will again rectify it. Okay, it will send back that refrigerant back to the absorber. Okay, so there are other two components which are used along with generator. Okay. Now, if we talk about the COP of vapor absorption refrigeration system, COP of a vapor absorption refrigeration system, basically this vapor absorption refrigeration system consists of a generator which is having temperature of Tg, and it also consists of a condenser. It also consists of a absorber. Suppose absorber is having temperature of Ta, and an evaporator which is having temperature of Te, and they reject their heat to atmosphere or surrounding. Okay, surrounding which is having temperature of T0. Okay, so they will reject their heat to surrounding which is having temperature of T0. Okay, so heat rejection will take place in the condenser and absorber in the case of vapor absorption system, and this is generator which will supply the heat to the condenser, and this evaporator will supply the heat. The heat will be supplied in the evaporator and it will send that to the absorber. Okay. Now, how to find the COP of a vapor absorption refrigeration system? If a vapor absorption refrigeration system is given to you in the exam, you can find the COP by using only three temperatures: Tg, generator temperature, evaporator temperature, and atmospheric temperature. So you have to find the three temperature in degree Kelvin. You have to convert the temperature in degree Kelvin. Okay, after that you have to, between these two temperature, you have to apply the formula of efficiency. Okay, so basically Tg, Te and T0, the three temperature. Between Tg and T0 apply the formula for efficiency, and between them apply the formula for COP of a refrigerator. Okay, and multiply this efficiency into COP of refrigerator, you will get the COP of a VARS system, of vapor absorption refrigeration system. Okay, suppose generator temperature is given as Tg, so it will be 1 minus of T0 over Tg. This will be the efficiency, and what will be the COP? It will be T over, T is the lower temperature, over T0 minus Te. Okay, so you have to just find the three temperature, that is generator temperature, evaporator temperature and surrounding temperature. Put this value in the formula of efficiency and COP, and you will get the COP of a vapor absorption refrigeration system. Okay, so this is all in the case of vapor absorption refrigeration system. This is a very important formula, and this formula is very important because this will be used to find the COP in the case. In the exam, there can be a question to find the COP. Okay. Okay, so here I am not here to tell you the working of that components because it is an important formula discussion class. Still, I have told you a lot of things, but I cannot discuss the schematic diagram here. Okay, because this is a particular class, is not for discussing the content. This is only for formula discussion. Okay, and to know the content part, you can go on to the lecture of vapor compression refrigeration system. Okay, So this is all the formula of vapor compression and refrigeration system. If you compare the COP of VCRS and VRS, it has high COP, it has low COP, it is work operated, it is heat operated, work operated. Okay, so here this VCRS system is basically used where there is abundant supply of electricity is there. We use VCRS system, and VRS system is basically employed in solar refrigeration uses VCRS system, and Electrolux refrigerator is uses VRS system. Okay, in the Electrolux refrigerator, normally there are three working fluids are used. Ammonia, water is a common working fluid which is used in VRS. Along with that, hydrogen gas is also used in the Electrolux refrigerator. The purpose of using the hydrogen gas is to reduce the pressure. To reduce pressure of the refrigerant, we use hydrogen gas in the case of Electrolux refrigerator. Okay, this question can be asked in the exam, that why hydrogen gas is used in the Electrolux refrigerator in the VRS system. Okay, so these were some important formulas that I have to discuss with you from the topic of air standard cycle, VCRS cycle and VCRS system and VRS system. Okay, this was what we have covered today in this week of free YouTube course of RRB SSC JE. Okay, so these topics were covered in this week, and so these are the formulas that were very important from these topics. Yes, calculators will be provided to you in the CVT2 exam. Virtual calculator will be given to you, so you can use the virtual calculator in the exam for doing the calculation. Okay, and one more important thing that I want to tell you here is that these formulas are only from the three topics, that is air standard cycle and vapor compression refrigeration system and vapor absorption refrigeration system, that we have covered in this week. Okay, those who have not gone through the lecture of these three topics, you can go on this lecture. The lectures are provided in the YouTube channel itself. Okay, if you have not watched the lecture, you can watch it again. Okay, and this lecture is absolutely free on the YouTube channel, so you can watch them. And so this is all the important formula discussion, and in the end I only want to say that in the next week I'm going to start with power plant subject. In the power plant I will be covering three important topics, which is boiler classification, mounting and accessories, and Rankine cycle and Brayton cycle. That will be covered in the next week, which is also very important from RRB SSC JE exam. Okay, so that will be covered in the next week, and further there will be important question discussion and formula discussion in the next week. Okay, so I will meet you on Monday. Till then, thank you and have a good day. In the end, I only want to say that those students who want to prepare for have a full-fledged preparation for RRB SSC JE, still we have provided a paid course called Focus JE Mech. Okay, in the Focus JE Mech paid course, we are covering 100% syllabus of RRB and SSC JE exam. Okay, and in that syllabus we are not only providing the lectures, we are providing the lectures and study notes, and we are also providing the quizzes, daily quizzes for each and every topic. And apart from that, there are important discussion classes. Weekly quizzes are also provided to you, weekly quizzes, and further mock tests. These are the feature of this course. Okay, you can purchase this course. The link are given in the description of this video. The cost of the course is 8450. The sale period is, I think, up to 31st of July. So you can buy the paid course up to that date. Okay, or it is up to 10th of August. But if you have to buy the course, you should buy it early, because then your preparation will be on time. Otherwise, you will lag behind the other students. Okay, so you can buy the paid course. The sale is still going on. The link for the paid course are given in the description of the video. And those who don't want to buy the paid course, you can follow our YouTube course also. We have no problem with that. Okay, and so the YouTube courses, in the YouTube course we will be providing some important question classes like we are providing you here. But if you want to have 100% syllabus preparation, you can purchase our paid course also. Okay, so this is all the very important information that I need to share with you. If you talk about the, see, most of you have this doubt that whether this thing is the syllabus or not, this thing is in the syllabus. See, we are not providing this content like from our own side. This is from RRB and SSC JE syllabus. Okay, so this is a part of syllabus, that's why we are providing it, we are covering it. Otherwise, whatever which is not mentioned in the syllabus, we are not covering that thing. Since this course is for both RRB and SSC JE, so we are providing common syllabus for both RRB and SSC JE. And boiler classification, mounting and accessories is in the syllabus of RRB and SSC JE, so that's why I'm covering it. Okay, so thank you so much for your response and for giving time here. And those who wants to prepare from our Gradeup, you can download our Gradeup app and you can follow our classroom feature on the Gradeup app. There you can follow our video online live classes. You can access our live classes from our classroom feature, and you can join the Gradeup today and get smart with our expert faculties. Okay, so I will meet you in the next lecture on Monday for power plant. Till then, thank you and have a good day. And those who have any doubt about the cutoff, I only want to say, I have told it so many times that the cutoff for general category student will be 60 to 65 for general category student, and this can be reduced for 4 to 5 marks after normalization. And for OBC candidates, this cutoff can be up to 55 to 60. For SC/ST, for SC category student, it will be 50 to 55 or from 45 to 50 for SC. This will be the cutoff till as per now. And after normalization, there can be a reduction and increment in the cutoff by 5 marks. Okay, so this is a very important information that that is also required for you. And yeah, everything is important. If you think this is not important, see, boiler, you can go into the syllabus of RRB SSC JE. Boiler classification, mounting and accessories is there in the syllabus of SSC JE or RRB JE. It is common syllabus of both RRB and SSC JE. That's why I have including that in the lecture also. Okay, if you don't want to study, it's up to you. We cannot force you for that, but we are providing that thing just because it is mentioned in the syllabus. Nothing is provided which is outside the syllabus. Okay, so thank you so much. I will meet you in the next lecture of boiler classification on Monday. Till then, thank you and have a good day. Thank you.